Hi there, this is Jacob Nash, Algebra Lessons, and this is Unit 1, Lesson 8 on inverses of functions. So what are inverses of functions? Well, anytime you have an inverse, it just means the opposite. So, in an inverse function, whatever the x values are, and whatever the y values are, switch. So, let's say we had, we can look at the inverse of relations. So let's say we had a relation that had 1, 3, 4, 5, and then 8, 9 for the values. And let's call this relation R. The symbol for doing an inverse is just, it looks like you're doing to the power of -1. So what would be the inverse relation? You just flip around each of the things. So you have 3, 1, 5, 4, 9, 8. So if you see, we have the x values here, and then the y values here. But then now, they switched around. That's what an inverse does. So when there's a function, what's that going to look like? Let's see. So let's say we had a function f of x equals 3x minus 5. What is the inverse function, which you would say is this? Okay, well, how do you solve for that? Well, remember, fx basically just means y, but it's just to help you remember that the x is a part of what it is. So they have a relationship with each other. Sorry. So basically this is y. We can just say that. But we know that we have to switch y into x to do that. So that's what we do. We switch the y into x. So we have x equals 3y minus 5. Because we switched the y and the x. Now it's xy. We switched it. Now you just solve. You're supposed to solve for y to figure out what this is. Okay, so we add 5 on both sides. So now we get that 3y equals x plus 5. You divide by, or not y, 3. And then you get that y equals 1/3 x plus 5/3. And you can just replace y with inverse f of x. So that's what inverse f of x equals. 1/3 x plus 5/3. So there you go. That's what it is. So let's go over to the graph now. Oh, sorry for seeing this, because I originally was going to do a review, but I can't anymore. Sorry. Let's see. Can I zoom out? Zoom out. I don't know. This is not how it was last time when I used this thing. How do I zoom out? Okay. Well, this is just what we'll have to deal with, I guess. I don't know why that happened. Okay, so let's look at two examples of two inverse functions. So two inverse functions, not using the examples that we did last time for this purpose, but let's just think of a random example. Let's just say, oh, I clicked on the wrong thing. J of x equals 2x plus 4. After we would solve for the the inverse, we would find out that it equals 1/2 x minus 2 if we solved that. So these are two inverse functions. Let's graph them and see what they look like. So let's graph the first one, 2x plus 4. So 4 is the y-intercept, so that's going to be right here. So that means if the slope is 2, we do up to right 1 over and over, or down to left 1. So we get the points. The point is there. There's another point here, 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 and here. So now let's connect this thing. Okay. And almost there. There. And other arrowhead. So that is function j of x. Let's look at what j of x inverse is. So that has a y-intercept of -2. So that's going to be right here. And it has a slope of 1/2. So that's going to be up 2, right, or sorry, up 1, right 2. And then also down 1, left 2. Okay. Now we draw that out. And that's what inverse j of x is. So, yes, that's what it's like. Now, well, what do we notice? Well, we notice that there is one point where they connect, and that's right here. That's at the point -4, -4. Well, why is that, huh? Well, that's because all of the points at which these functions land on, they need to be reversed to get to the other function. So, for example, we have -2, 0. Well, that means 0, -2. They're inverses. But you can't, if you have -4, -4, you can't flip that around. So that's why that's the same thing for both of them. Okay? Also, functions always have symmetry on the y equals x axis. So y equals x axis basically just means this. So it has a y-intercept of 0, so that means right here, and it has a slope of 1, so you go up 1, right 1, so you're basically just going by one grid, and that's what it is. So let me keep drawing this. Wish this thing could zoom out. Let me see. Okay. It just goes away from it anytime I try to do that. It's dumb. Okay. Down here. And we'll just try to draw this to scale. And if you think about what is the inverse of the y equals x line, well, it's going to be itself, because every value that the y equals x line goes through is values that are the same for the x and y. So that's what that is. And there's symmetry along that. So if you folded, we have here a pretty much square-like grid. So that's not a square, really. Let me just draw it down here. We have this grid, but if we folded it on this line, so we folded this part over, these two lines, which are like right here and then here, they would line up with each other. So they would be like over top of each other like this. So there you go. That's what that is. So that's really all there is to inverses. When you're looking for an inverse, that's all you need to do. So that would be it for this video and unit, and I'll see you next time on Unit 2. Thanks for watching.